This custom backyard pergola hides a 6-kilowatt solar array that powered an entire house with zero draw from the grid during a live cut test. It outproduces rooftop panels by staying cooler underneath and delivers shade value that rooftop installs never offer. Yet, despite costing less than a standard grid-tied system, almost no permit office has a category for it, and no appraiser will add it to your home value. It's called a solar pergola. By the end, you'll know what it is, how it works, and how to build your own. Let's dive in. Right now, the average American household pays about $147 a month for electricity. That is $1,764 a year disappearing from your bank account before you flip a single light switch. And the direction is only going one way. The Energy Information Administration reported that residential electricity prices rose over 20% between 2018 and 24. In some states, the increase was worse. Texans saw bills spike nearly 30% during the same window. So, you do what everybody tells you to do. You call a solar installer. He walks your roof, measures your south-facing pitch, and hands you a quote somewhere between $18,000 and $25,000 after the federal tax credit. You sign. The crew bolts 30 or 40 panels flat against your shingles, and then you wait for the savings to arrive. But here is what nobody in that sales meeting brought up. Those panels are sitting directly on your roof deck, baking against asphalt shingles that can reach 160 degrees Fahrenheit in a July afternoon. Solar cells lose roughly 0.5% of output for every degree Celsius they climb above their rated temperature of 25 degrees Celsius. That relationship is called the temperature coefficient, and every panel datasheet lists it. On a 95-degree day in Phoenix, Dallas, or Atlanta, your panel surface temperature can hit 70 degrees Celsius or higher. That is a 45-degree overshoot, which translates to a 20 to 22% loss in nameplate capacity just from thermal derating. You paid for 6 kilowatts. On the hottest afternoons, when your air conditioner is working its hardest and you need every watt, you are getting 4.7 at best. And that is before soiling, wiring losses, and inverter clipping take their cuts. Meanwhile, the shingles underneath those panels are suffocating. Airflow is choked off. Moisture collects between the module frame and the roof surface and has nowhere to go. Roofers across the Sun Belt, from Houston to Tucson to Jacksonville, report accelerated shingle degradation under flush-mounted solar arrays. Some estimate it cuts roof life by a full third. So your 20-year solar investment is sitting on a roof that may need a full tear-off and re-shingle in 12 or 13 years. And when that day comes, you pay a crew between $3,000 and $5,000 just to pull the panels, store them safely, and remount them after the new shingles go down. Nobody puts that number on the original sales proposal. Now, here's the question that changes this entire calculation. What if the structure holding your panels was not your roof at all? What if it was something you would have built anyway? Something that made your backyard more useful on the same day it started generating power? And what if that structure actually made the panels perform better than they ever could, bolted flat against shingles? That is exactly what a solar pergola does. And when you see the real cost per kilowatt hour compared side by side with a conventional rooftop system, the math is going to rearrange everything you thought you knew about residential solar. The core concept is so straightforward, it almost feels too obvious. You are building an outdoor structure, a pergola, an arbor, a patio cover, whatever your county calls it. Instead of capping it with wood slats or a corrugated polycarbonate sheet, you cap it with solar panels. The panels become the roof. They are tilted at the optimal angle for your latitude, typically between 25 and 35 degrees across the lower 48 states. And because they are elevated 8 to 12 feet off the ground with open air circulating freely beneath them, they stay dramatically cooler than roof-mounted modules. That airflow is the key to the entire performance advantage. A roof-mounted panel traps a layer of superheated air between itself and the shingle deck. There is nowhere for the heat to go. A pergola-mounted panel has nothing below it but open sky and rising convective currents. On the same 95-degree day that costs a rooftop panel 20% of its output, a pergola panel runs 15 to 20 degrees Fahrenheit cooler at the cell surface because natural ventilation pulls heat away continuously. The result is not theoretical. Engineers at the National Renewable Energy Laboratory in Golden, Colorado, have documented that improved airflow behind photovoltaic modules recovers between 5 and 10% of annual energy yield compared to flush roof mounts. That data comes from instrumented field studies, peer-reviewed and publicly available through NREL's technical report library. Think about what those percentages mean in your pocket. A 6-kilowatt array in a decent sun state like Texas, North Carolina, or Colorado produces roughly 8,000 kilowatt hours per year under standard conditions. A 10% ventilation recovery is 800 extra kilowatt hours annually, at the national average retail rate of about 16 cents per kilowatt hour. That is $128 a year in electricity production you would never have captured on your roof. Over a 25-year panel lifespan, that is $3,200 in recovered energy simply from letting air move underneath the modules. Now, if you are thinking that range sounds too wide, that 5 to 10% is vague enough to hide a disappointing real-world result, researchers at Sandia National Laboratories in Albuquerque addressed exactly that concern. They instrumented identical panel models in both flush mount and open rack configurations across multiple U.S. climate zones and published comparative results. Open rack modules consistently operated at lower cell temperatures and produced more energy per rated watt in every test environment. Desert sites like Albuquerque showed gains near the top of that range. Temperate sites in the Pacific Northwest showed smaller but still positive gains. The physics behind this is not exotic. It is textbook thermodynamics. A hotter semiconductor junction converts less light to electricity. A cooler junction converts more. A pergola is simply a structure that keeps the junction closer to its rated operating temperature. But raw panel output is only half the value story. The other half is dual use. When you bolt panels to your roof does not become more enjoyable. You cannot sit under rooftop panels and eat dinner. A solar pergola gives you a shaded outdoor living space you use every single day. In Sunbelt states like Texas, Arizona, Nevada, and Florida, a well-built covered patio adds genuine livable square footage to your property. Remodeling contractors in those markets estimate that a quality pergola adds between $8,000 and $15,000 in perceived home value. And the shade does more than improve your weekend. The Department of Energy estimates that strategic shading on south and west-facing exterior walls can cut residential cooling costs by up to 25% in hot climates. That means the pergola reduces your electric bill twice, once by generating power, and again by cutting the amount of power your air conditioner needs to consume. Here is where the pergola concept connects to something much older than photovoltaics. Humans have been building elevated overhead structures to manage solar heat gain for millennia. The Roman peristyle garden used columned walkways and slatted overhead trellises to create shaded courtyards that stayed cool through brutal Mediterranean summers. That same principle, intercepting direct sunlight above head height and letting heated air escape vertically, is exactly what a solar pergola does. The only difference is that the overhead surface now converts photons into electrons instead of merely blocking them. The modern research behind elevated solar canopies gained momentum in Europe around 2011, when scientists at the Fraunhofer Institute for Solar Energy Systems in Freiburg, Germany, began publishing field data from agrivoltaic installations. These structures mounted solar panels 5 to 7 meters above active farmland. Panels generated electricity overhead, while crops grew in filtered light below. Fraunhofer's multi-year trials showed that combined land use efficiency, electricity plus agricultural yield, increased total site productivity by over 60% compared to dedicating the same acreage to either use alone. That dual-use framework crossed into residential design by 2015. A research team at the University of Miyazaki in Japan published complementary findings in 2014 showing that elevated mounting improved both panel electrical output and usable ground area across a range of tilt angles and climatic conditions. And yet, despite over a decade of peer-reviewed, replicated research from 3 continents, the residential solar industry in the United States still treats the Pergola form factor as a curiosity. Installers are trained to sell roof mounts. Financing products are underwritten around roof mounts. The entire permitting conveyor belt was built for roof mounts. Anything outside that template falls through the cracks. Now, let me show you what happens when someone actually builds one and pulls the plug on the grid. A homeowner in Central Texas constructed a custom pergola in his backyard using pressure-treated 6x6 posts and a welded steel top frame angled at 30 degrees south. He mounted 18 335-watt monocrystalline panels across the top, producing a clean 6-kilowatt array. Total panel cost was around $3,600, purchased direct from a wholesale distributor. The structural frame, stainless steel hardware, and concrete footings added another $2,200. He wired the array into an EcoFlow whole home battery gateway, which manages power flow between the solar input, a lithium iron phosphate battery bank, and the home's main electrical panel. Then, he did something most solar owners never attempt. He ran a live grid cut test. He walked to the meter, pulled the main breaker, and disconnected the house entirely from the utility. Every single appliance kept running. The refrigerator hummed along, the air conditioner cycled on and off normally, the well pump pressurized on demand. The internet router and modem never dropped a connection. 0 watts from the mains. The EcoFlow gateway handled the load balancing automatically, drawing from live solar production during daylight and switching seamlessly to stored battery power after sunset. His total build cost, panels, lumber, steel, hardware, wiring, and the EcoFlow gateway system, came in under $12,000. A comparable rooftop install with battery backup in his market area was quoted at $28,000 before the federal tax credit. Even after the 30% investment tax credit, the rooftop option was still north of $19,000 out of pocket. His pergola beat it by $7,000 and gave him a covered patio he uses every evening for dinner. Over in Albuquerque, a retired electrical engineer named Don Harlan built a similar structure on a 16 by 20-foot footprint. He chose extruded aluminum rail framing to save weight and eliminate corrosion concerns in the high desert climate. His 20-panel array produces roughly 7.2 kilowatts at peak. Paired with a battery system and a small propane backup generator for extended winter cloudy stretches, Harlan reported that from March through October, his electric bill hit 0. Not low, not discounted, 0. His total materials cost came in just under $9,000 because he performed all labor himself and sourced panels through a group buy organized on the DIY Solar Forum, a community with over 40,000 registered members. Down in rural Georgia, a small homesteader mounted 12 400-watt panels across a cattle shade structure, creating a 4.8 kilowatt array that doubles as sun protection for livestock. Her system produces an average of 22 kilowatt hours per day, enough to cover her full household load, plus a chest freezer in the barn. She reported a payback period of under 4 years, based on her previous average monthly bill of $92. And here is a number worth sitting with. The Solana concentrating solar plant near Gila Bend, Arizona, stores thermal energy in molten salt and continues producing electricity at full rated output for 6 hours after sunset. No residential rooftop photovoltaic system on Earth can match that without a battery. That same principle, decoupling the moment of generation from the moment of consumption, is exactly what a pergola with battery storage achieves at household scale. So, if this works this well, costs less, and performs better in heat, why does your solar installer not even mention it? The answer has nothing to do with physics, and everything to do with how the residential solar machine is built. Start with permits. Most municipal building departments maintain 2 solar permit categories. One is a rooftop solar permit, handled under the electrical code, usually requiring a structural engineering letter confirming the roof can handle the additional dead load. The other is a ground mount permit, treated as an accessory structure, and triggering zoning setback rules, height limits, and sometimes lot coverage calculations. A solar pergola fits neither track cleanly. It is not on the roof, so the expedited rooftop solar permit path does not apply. But it is not a conventional ground rack either, because it is a habitable shade structure with occupiable space underneath. Many jurisdictions force it into the full accessory structure review, which means architectural drawings, sometimes a structural engineering stamp, and a 4 to 8 week approval timeline. Installers despise that timeline. Their entire business model is built around speed. Sell the job Monday, pull the standard rooftop permit by Wednesday, install on Friday, and move to the next house. A solar pergola jams that conveyor belt cold. Now here is what happens when you try to finance one. Most residential solar loans and power purchase agreements are underwritten on the assumption that panels are physically fastened to the roof of the home. The lien structure, the hazard insurance requirements, and the performance guarantees all reference the roof as the mounting point. A pergola-mounted array does not check that box. Lenders either decline the application outright or reclassify it as a general home improvement loan at a higher interest rate, often 2 to 3 percentage points above the solar-specific rate. On a $15,000 loan, that difference adds $3,000 to $4,000 in interest over the loan term. The federal investment tax credit itself is mount agnostic. Section 48 of the Internal Revenue Code allows the 30% credit for any qualified solar electric property placed in service at a taxpayer's residence. The statute does not mention rooftops, but the installer's quoting software, the loan officer's drop-down menu, and the permit clerk's intake form all default to roof mount. If it is not a roof job, it does not glide through the pipeline. Nobody is conspiring against pergola solar. The entire processing infrastructure was simply never designed to handle it. Then there is the appraisal wall. Fannie Mae's residential appraisal guidelines link solar value to owned, permanently attached rooftop systems. A pergola-mounted array that is not structurally fastened to the dwelling may not qualify as a permanent improvement in the appraiser's judgment. When you sell your home, the appraiser might record 0 additional value for your 6-kilowatt power plant sitting 10 feet from the back door. The covered patio structure itself gets valued. The panels generating your electricity on top of it may be invisible in the transaction. That structural invisibility is the real reason no national solar installer actively markets pergola systems. The permits take too long, the financing does not template, the appraisals miss the value, and the profit margin per job is thinner than a cookie-cutter roof install. It is not a conspiracy. It is institutional friction at every link of the chain. Here is how you actually build one. You need 4 main components: posts, top frame, panels, and the electrical backbone. For posts, pressure-treated 6x6 lumber rated for ground contact is the standard choice. A 12-foot post sunk 3 feet into a concrete footing gives you 9 feet of clearance underneath, which is comfortable standing height with room for a ceiling fan or hanging string lights. You need 4 to 6 posts, depending on your planned span. Budget $30 to $40 per post at current lumber prices, and another $15 to $20 per footing in 80-pound bags of pre-mixed concrete. For the top frame, you have 2 proven options. Steel angle iron, typically 2-inch by 2-inch by 3/16 inch, is strong, weldable, and affordable. A full top frame for a 12 by 16-foot pergola runs $400 to $600 in steel at current US prices. The alternative is extruded aluminum solar rail from manufacturers like Iron Ridge or Unirack, designed specifically for panel mounting with integrated mid-clamps, end clamps, and splice kits. Aluminum rail for the same footprint runs $700 to $900. Both options perform well. Steel requires either welding or bolted connections, and a coat of Rust-Oleum or equivalent rust-preventive paint every few years. Aluminum requires no welding and handles decades of weather without any surface treatment. For panels, 330 to 400 watt monocrystalline modules are the current value sweet spot. Wholesale pricing through distributors like Signature Solar, based in Texas, or Santan Solar in Arizona, runs between 80 cents and $1.10 per watt, depending on brand and order size. An 18-panel 6-kilowatt array costs between $3,000 and $4,000. One critical warning here: avoid no-name panels that lack a UL 2703 listing. A module without that certification may void your homeowner's insurance coverage and will almost certainly fail any permit inspection in a code-compliant jurisdiction. For the electrical system, the EcoFlow Delta Pro, paired with the Smart Home panel, or the newer Whole Home Gateway, handles solar input, battery storage, and automatic transfer switching between grid-tied and off-grid operation. The Delta Pro with Smart Home panel runs about $4,500 at current retail. For full whole home backup without load shedding, the Gateway configuration with dual Delta Pro batteries runs closer to $8,000. You will also need a PV combiner box rated for your string voltage, appropriately sized wiring. 10-gauge copper is standard for most DC home runs under 50 feet, and a proper grounding system, including a copper ground rod and equipment bonding conductors. If you are not confident with DC electrical work, a licensed electrician can complete the final connections from combiner box to gateway in 3 to 4 hours. Budget $200 to $300 for that service call. The structural skill level required is moderate. If you can operate a post hole digger, a circular saw, and a cordless drill, you can build the frame. Most documented builds take 2 to 3 weekends with one helper. Do not skip the grounding under any circumstances. An improperly grounded array on a metal frame is both a lightning risk and a code violation in every jurisdiction. There are honest limitations you need to weigh before you pour the first footing. First, a solar pergola requires yard space with strong solar access. If your backyard faces north, or if mature trees or a 2-story neighboring house block the southern sky, your annual production will drop significantly. You need a south-facing or near-south footprint with minimal shading between 9 in the morning and 3 in the afternoon year-round. Second, a pergola is a permanent structure. In most jurisdictions, it triggers a building permit requirement. In neighborhoods governed by a homeowner association, the HOA may enforce aesthetic guidelines or outright bans on visible solar equipment. Read your CC and Rs before you order a single post. Third, panels alone do not store electricity. Without a battery bank, you are still grid-dependent after dark and during extended cloudy weather. The pergola generates power. It does not hold it. That distinction matters when you are planning for true off-grid resilience. So, here is the comparison one final time, stripped to its essentials. A conventional rooftop solar install with battery backup runs between $22,000 and $30,000 before the tax credit across most U.S. markets. After the 30% federal credit, you are at $15,000 to $21,000 out of pocket. That system sits on your shingles, traps heat beneath the modules, accelerates roof degradation, adds zero usable outdoor space, and costs $3,000 to $5,000 to remove and reinstall when the roof needs replacing. A solar pergola with the same 6-kilowatt capacity and battery backup can be built for $8,000 to $12,000 in materials. It runs cooler, produces 5 to 10% more annual energy, gives you a shaded outdoor room you will use every week, and never touches your shingles. That is the same electrical output for roughly half the cost, plus a covered patio that actually improves your daily life. If you want to power, heat, and cool your home off-grid, the Passive House files show you how. Full plans, exact materials, and the honest numbers nobody else gives you. It's not too late to start lowering your bill. Scan the QR code and see for yourself. So here's my question for you. If you had the budget for one project this summer, would you build a solar pergola in your backyard? Or would you go with a conventional rooftop install to keep the tax credit paperwork clean and the permitting fast? Drop your answer in the comments because that split tells me exactly what to cover next. If this breakdown saved you real money or put an option in front of you that nobody else had mentioned, Subscribing and sharing is the single best way to help this channel keep producing these deep dives. Next time, we are tearing apart a concrete thermal battery that stores solar heat for under $200 in materials and keeps producing warmth even in northern states where the sun vanishes for weeks at a stretch.